Hello, we're going to go through section 5.5, which is theorems about roots of polynomial equations. You'll want to grab a graphing calculator if you don't have one on your desk. What this lesson is going to be asking for the first type of example is to find the possible and the actual roots. So what that means is to find the possible ones, we're going to take a look at, if this is the first example, 2x cubed minus x squared plus 2x plus 5, we're going to take a look at the leading coefficient and then the last term. So the leading coefficient is 2, the last term is 5. So we're going to write those down. The last term we're going to write on top, the leading coefficient we're going to write on bottom. And then we're going to write all the numbers that divide evenly into both of those numbers. So the numbers that divide evenly into 5 are 1 and 5. The numbers that divide evenly into 2 are 1 and 2. So now from here, we have to take all the last terms divided by all the first terms. So we're going to start with the 1. 1 divided by 1 is 1. 1 divided by 2 is a half. And then now we're taking this 5. So 5 divided by 1 is 5. 5 divided by 2 is 5 halves. Now you want to make sure that you reduce the fractions. You can leave it in fraction form or decimal form. In front of each of these numbers, there should be a plus or minus sign. If you want to just do what I did and put a plus or minus sign out front, that works also. But just know that this is a list of 8 numbers, all the positive and all the negatives of each of these numbers. Now, this list of possible ones, we know looking at the graph just off of the degree that it can have only a total of 3 solutions because that's the highest exponent. We have 8 possible solutions, so it's not going to cross through all 8 of those, but that's where it could. So it's a check and balance. Once we graph this now, let's say it crosses at 3/4, we know that we graphed it incorrectly because that's not one of our solutions on our list of possible ones. So let's take a look at our graph. I'll give you some time to graph it as I'm graphing it. And once we have it typed in, make sure we have it typed in correctly. And then we're going to click graph. And what we're looking for the actual ones is where does it cross the x-axis. It doesn't matter where it crosses the y-axis, but solutions are where it crosses the x-axis. So notice it crosses right here at the x-axis. So we want to find what that solution is. So we're going to go to second, calculate. We're going to go to where it says 0. It says to the left bound. So we need to go to the left of that solution, and then we need to go to the right of it. Click enter, enter. And then it says -1, 0. So on our list of actual ones, it's going to be x equals -1. And you can just put x equals the number because the y is always going to be 0, or you can write it as a coordinate -1, 0. And there's only one actual solution because it only crosses the graph at one place. So that means since there's a total of 3 of them, the other 2 are going to be imaginary solutions, and they just want the rational number, so we don't need to find the 2 imaginary solutions, so we would be done at that point. So let's try another one. For this next one, we have 3x to the third power plus 7x squared plus 6x minus 8. Again, we're going to take that first term and then the last term. We're going to write the last term on top. So 8. You don't have to worry about the positive or the negative because we're going to put a plus or minus sign in front of each of them. And then we're going to put 3 on bottom. So all the numbers that divide evenly into 8 are 1, 2, 4, and 8. All the numbers that divide evenly into 3 are 1 and 3. Then we're going to take all these last terms and divide by all these first terms. So 1 divided by 1 is 1. 1 divided by 3 is 1/3. Now go to the 2. 2 divided by 1 is 2. 2 divided by 3 is 2/3. Now to go to the 4. 4 divided by 1 is 4. 4 divided by 3 is 4/3. Now the 8. 8 divided by 1 is 8. 8 divided by 3 is 8/3. If you have duplicates, you just need to put them once. And again, this plus or minus sign would go in front of each of these, or you can just put it out front and know that all of these are positive. All of these numbers are also negative. Now there's only 3 total solutions. Some could be actual real ones or imaginary ones. So it's not going to go through all of these when we graph it, but that's our possible list of where it could cross. So it's a way to check our answers as we go through now and find the actual ones. So let's graph this one. So we're going to delete that graph and type in our new one. So we get this graph. Notice it again, it just crosses at one place. So we want to find what that one solution is where it crosses the x-axis. So go to second trace, go down to 0. And then right here where the solution is, we want to go to the left of it and then to the right of it. So to the left of it, click enter. To the right of it, don't be putting the up and down arrows, just move left and right to move it to the left and to the right. Click enter and then guess, click enter one more time. And it says 0.6 repeating, which is just 2/3, and then 0. So 2/3, we have that. Again, you can put it as a fraction or a decimal, that is fine. So our actual solution would be 0.6 repeating or 2/3. All right, I have another example for us. So we have 15x to the third power minus 32x squared plus 3x plus 2. Our last term divided by our first term to find our possible ones. So we have 2 and 15. I always, again, put the last term and then the first term on bottom since it's last divided by first. So then our last term is 2, so 1 and 2 divide evenly into 2. 15, we have 1, 3, 5, and 15, all divide evenly into 15. So now we have to go through and take all our combinations. So 1 divided by 1 is 1, 1 divided by 3 is 1/3, 1 divided by 5 is 1/5, 1 divided by 15 is 1/15. Now we go to the 2. 2 divided by 1 is 2, 2 divided by 3 is 2/3, 2 divided by 5 is 2/5, and 2 divided by 15 is 2/15. We make our list. We put a plus or minus sign in front of each of those. So that's where it could cross through. Again, it's not going to cross through all of those. And then if we graph this, we want to see what the actual ones is. Now this one again is to the third degree or to the third power. So it could cross through 3 places. If it only crosses at one place, that just means the other 2 solutions are imaginary and you do not need to find them with our directions in this problem. So this one does cross at 3 places, so we want to find all 3 of those solutions. So we go to second trace, go to 0. We're going to go to the left of this one furthest to the left, click enter, and then scroll to the right of it, click enter, enter. And the first one is negative 0.2, or that's 2/10 or 1/5. And then we go to our next one. And we have to go to second trace again, but now we want to find this one. So we go to the left of it, which would be up here, click enter, go to the right of it, which would be down here, click enter again, and then it's 0.3 repeating or 1/3. And then we have to do second trace one more time, go to that 0 again, we go to the left of it, so down here would be to the left of that solution, go to the right of it, which would be up there, click enter, enter. And our last one is 2. And then notice this is 1.03 times 10 to the negative 11th power. They put it in scientific notation. That still just means, sorry that you couldn't see it, that is just 0. If we move that decimal back 11 places, that's how accurate it is going. So it would be 0.000, multiple zeros, and then 103. So that would just be 0. So 2, 0 would be our last solution. So we found all 3 solutions, 2, negative 1/5, and 1/3. Again, you can put them as a fraction or a decimal. Now I have one more of this type of example before we move on to the next problem. I'm going to give you some time to work it out, finding the possible and the actual ones. If you could pause and work it out, and then I'll show you the correct answer so you can check your work. Alrighty, please check your work. The possible ones would be plus or minus 1/2, 2, 3, 3/2, and 6. And then the actual ones, when we graph it, would be 2, -1, and -3/2. Alrighty, the second type of problem we're going to take a look at is using the conjugate root theorem. So for this one, they're going to give you some solutions. So we know square root of 2 is a solution and 1 plus I is a solution. And what it says are, what are the two other solutions or roots? So for this one, using that conjugate root theorem, it says that anytime there's a square root or an I, there should be a plus or minus sign in front of them. So this square root of 2 should have a plus or minus sign in front of it. So since we know positive square root of 2 is a solution, then the negative also has to be a solution. So negative square root of 2. And then since we know 1 plus I is a solution, there should be a plus or minus sign right here. So 1 minus I should also be a solution. So those would be the other two roots, since we know these two are solutions. So let's try another one. So we have 3 minus 2i and 5/2. Now this one has an I, so there should be a plus or minus sign directly in front of it. So since this is one solution, the other one should be 3 plus 2i. Now this 5/2 are kind of tricking you here. There's not an I attached to it, and there's not a radical sign over it. So since it doesn't have either one of those, you wouldn't need the plus or minus sign in front of it. So that would be the only other solution, would be 3 plus 2i. So just make note that anytime there's a square root or an I, that you should have a plus or minus sign in front of it. Now, the last type of problem that we're going to talk about in this lesson is now using those conjugates to construct a polynomial. So if we know -4 and 2i are solutions, this -4 doesn't have a radical, doesn't have an I attached to it, so just -4 is a solution. And then we know 2i is a solution. It has an I attached to it, so the negative is also a solution. We would have a plus or minus sign in front of it. So those would be our three solutions. Now what they want is a polynomial. They want the equation. So when we go to plugging these solutions into our parentheses, we plug in the opposite. So instead of -4, we plug in a +4. Instead of a positive 2i, we plug in a negative 2i. Instead of negative 2i, we plug in positive 2i. Now, if they just want it in factored form or say write the polynomial, you can leave it in this form. If they say put it in standard form in the directions, then I need you to FOIL it out. So to FOIL it out, these two that are opposites of one another, I would start with those first, because then the middle term should cancel out. So if we distribute this x to both of these terms, we have x times x is x squared, x times 2i is 2ix, and then distribute this negative 2i. Negative 2i times x is negative 2ix, negative 2i times 2i is negative 4i squared. Think of those i's just like an x's or any other variable. Don't think of it as an imaginary number. Now from here, the two middle terms just cancel out. And then I squared, anytime we have an I squared, that just equals -1. So we can substitute in here -1. So -4 times -1 would just be +4 there. So we have x squared, -4 times -1. Again, it's just +4. Now we can FOIL these two terms out. So distribute this x times x is x squared, or x to the third power, sorry. X times 4 is 4x. Distribute this 4. 4 times x squared is 4x squared. 4 times 4 is 16. Now we're going to put it in standard form, so exponents just highest to lowest. So these two middle terms, we're just going to switch them. So we have y equals x to the third power plus 4x squared plus 4x plus 16. Now both of these equations are the same thing. They're both polynomial equations. One's just in factored form, one's in standard form. So read the directions, see which format they would like the answer in. Let's try one more of these. So we have 2 minus 3i, 8, and 2 are our solutions. Since we know 2 minus 3i is a solution, then 2 plus 3i is also a solution. 8 and 2 doesn't have a radical over it or an I attached to it, so we don't put a plus or minus sign in front of those. So this one would have 4 total solutions. So then from here, we're just going to plug in the opposite. So it would be x minus 2 minus 3i, and then x minus 2 plus 3i. We didn't notice, just change that sign right in front of the plus or minus sign, or right in front of the I, sorry. And then this 8, we have x minus 8 and x minus 2. And then we can leave it in that form. That would be factored form. Or we could go through and distribute it out, and we would end up with this as our final answer. Y equals x to the 4th minus 14x to the 3rd plus 69x squared minus 194x plus 208. If you're curious on the assessments, I would take either answer, so this factored form or the standard form.